Good day, the topic is total pressure on vertical plane surfaces. Total hydrostatic pressure or force, F, is the equivalent resultant force equal to the product of the pressure and the contact area. That is, in formula form, F is equal to P, the pressure, multiplied with A, the contact area of the fluid. For the first case, for vertical plane, let us consider two methods of solution. So for the determination of force and location. First is the pressure diagram method. For the process, first, identify points at top and bottom of the submerged plane for the sample figure. Consider points A and B. Next is to determine the pressure at the pre-identified points. For homogeneous fluid or single fluid, use P equal to gamma times H. While for layers of fluids, consider P equal to P sub A or the air pressure plus the summation of P sub Li or the pressure contribution of the different fluids. And it is better to present solution in table form. So identify the points, depth H, and finally pressure P. For points, we have A and B. For H, it is a depth measured from free liquid surface. For layers of fluids, the column for H is not needed. At point A, since it is at free liquid surface, H is equal to 0. And at point B, H is equal to H. For P, at point A, P is equal to 0. And at point B, P is equal to gamma times H. Assign pressure values, so 0 at A and gamma times H at B. Draw the pressure diagram for pressure. It is uniformly increasing as the depth increases. Using this diagram, we can already estimate the value of the total force or the total pressure F, where F is equal to the volume of the pressure diagram, which is equal to the area of the pressure diagram, that is A sub T, multiplied to the sample width or the sample length. So for the sample diagram, F is equal to 1/2 times gamma times H times B. But assign the distance from free liquid surface to the center of gravity or CG as H bar. And for this sample, H bar is equal to H all over 2. Then area A is equal to H times B. Thus, simplifying the equation, F is equal to gamma times H bar times A. And for the location of F at the center of pressure or CP, that is distance Y sub P or centroid of the pressure diagram. For this sample, if measured until free liquid surface, it is 2/3 of H. But if it is from the bottom of the surface or the vertical surface, then consider 1/3 of H. And for pressure diagram that is not a triangular prism, consider concept of the moment area method or the Varignon's theorem. That is A sub T times Y sub C is equal to the sum of the moment or the individual moment of the different areas. So that is with respect to a common reference line. And take note that before you apply this equation, it is better if you will divide the diagram to triangular shapes. So before we continue, for some notes, first, the pressure and force are always perpendicular to the submerged surface. Second, you can use the identified equation for F and Y sub P if it satisfies the following criteria. First, only one fluid. Second, partially or submerged surface just at free liquid surface. And last, rectangular surface. For the last note, if the criteria or one of the criteria are not satisfied, then consider the process of pressure diagram. Okay, so let's take now the second method, which is the direct method. So it is an ideal method because it is flexible and easy to use for any shape of the surface. First is for total pressure F. For homogeneous fluid or single fluid, F is equal to gamma times H bar times A, wherein gamma is the unit weight of the fluid, H bar again is the distance from CG to free liquid surface, and A is the area of your submerged surface. For layers of fluids, which is applicable only if the surface is exposed to only one fluid. If not, then use the pressure diagram method. So for these layers of fluid, use F is equal to bar P times A, where bar P is the sum of the pressures of fluids at the center of gravity of the submerged surface. And next, for the location y sub P is equal to H bar plus E, where eccentricity E is equal to the moment of inertia along the neutral axis of your vertical plane surface over A, that is the area of the surface, then multiply to H bar. So for common shapes, the moment of inertia R. For rectangular surface, we have I equal to 1 all over 12 times B times H raised to 3. For triangular surface, we have I equal to 1 over 36 times B times H raised to 3. While for circular surface, we have I as pi multiplied with radius raised to 4 all over 4. So let us now take our sample problems. So for problem number 1, a vertical rectangular plane of height 6 meters and base 3 meters is submerged in water with its top edge at the liquid surface. Determine the total force F acting on one side and its location from the liquid surface. So for method 1, that is the pressure diagram. So assign points A and B at the top and bottom of the submerged surface. For homogeneous fluid, again use P or the equation of pressure as gamma times height. Presenting in table form, identify points H and P. For points, we have A and B. For H, that is measured from free liquid surface. At A, H is equal to 0. At B, H is equal to 6 meters. And therefore, P at A is 0 since H is 0. For point B, it is equal to 9.81, the unit weight of water, times H, that is 6 meters, equal to 58.86 kilonewtons per square meter. And with these values of P, assign now the different values at points A and B. Then, draw the pressure diagram. Next is to determine the value of force F and location Y sub P. For F, it is equal to the volume of the pressure diagram, or A sub T, the area of the pressure diagram, times L, the width of the surface. Substitute values. F, therefore, is equal to the area of the pressure diagram, that is triangular, so 1/2, times the base, which is 58.86 kilonewtons per square meter, times the height of the sample side of that prism, which is 6 meters. Then multiply to the width or the base of the submerged surface, which is 3 meters. Thus, F is equal to 529.74 kilonewtons, that is towards the surface. Next is the location from free liquid surface, represented with Y sub P. For this problem, Y sub P is equal to 2/3 of H. Substitute the height, that is 6 meters. Then Y sub P is equal to 4 meters from free liquid surface. Next, solving the problem using method number 2, the direct equation. Determine the value of F. For homogeneous fluid, use F equal to gamma times H bar times A. Substitute values. Gamma of water is 9.81 kilonewtons per cubic meter, while H bar is half of the total height, that is 6 meters, therefore it is 3 meters. Then multiply to the area of the surface, that is with base 3 meters, times the height 6 meters. Therefore, for F, that is 529.74 kilonewtons, again towards the surface. For the location Y sub P, from the diagram, Y sub P is equal to H bar plus E. For eccentricity E, it is equal to I all over A times H bar. And for I of rectangular surface, it is equal to 1 all over 12 times B times H raised to 3. Substitute the values. We have B as 3 meters, H 6 meters, and H bar as 3 meters. Therefore, E is 1 meter. Substitute in equation of Y sub P, we have YP as equal to 4 meters from free liquid surface. Again, the same as the first method answers. Next is problem number 2. A vertical rectangular plane of height 3 meters and base 2 meters is submerged in water, with its top edge 1.5 meter below the liquid surface. Determine the total force F acting on one side and its location from the liquid surface. For method number 1, the pressure diagram, assign points A and B at the top and bottom of the submerged surface. For homogeneous fluid, P is equal to gamma times H. In table form, identify points H and pressure P. For points, we have A and B. For H, that is measured from free liquid surface. At A, H is 1.5 meter, while at B, that is 4.5 meters. Again, this is the total value of H from free liquid surface. So for P at A, the value is 14.715 kilonewtons per square meter. And at B, 44.145 kilonewtons per square meter. Assign these values at A and B. Then, draw the pressure diagram. Next is, determine the value of force F and location Y sub P. For F, it is equal to the volume of pressure diagram, or A sub T, the area of the pressure diagram, multiplied to L, that is the width of the surface. Substitute the values. F therefore is the area of the trapezoid equal to 1/2 times base 1, which is 44.145, plus base 2, that is 14.715, and multiply to the height of the trapezoid, that is 3 meters. After we compute the area, multiply the following to the width of the surface, which is 2 meters. Thus, F is equal to 176.58 kilonewtons, that is towards the surface. Next is the location from free liquid surface. But since the pressure diagram is not triangular, then apply the moment area at the reference line, which is set at the top of the diagram. So rearrange the equation before we apply this. So let us divide the pressure diagram to triangular shapes. So we have triangles 1 and 2. Next is to assign the centroid location of the area and the corresponding moment arm y. Update the equation with the two shapes. Therefore, we have y sub c is equal to a sub 1 times y sub 1 plus a sub 2 times y sub 2 over the total area, which represents the pressure diagram. Okay, so assign and substitute the values in the equation. Therefore, y sub c is equal to, so for our first shape, we have 1/2. So the area is the area of the triangle. So 1/2 times the base, which is 14.715, times the height of the triangle, which is 3. And multiply to the lever arm, which is the centroid distance with respect to the reference line, that is 1/3 of 3 meters. Plus, for the second shape, we have 1/2 times the base of the triangle, 44.145, multiply to the height of the triangle, 3 meters. And multiply with the lever arm. So for the centroid, we have 2/3 of the total height, which is 3 meters. So quantity, this will be divided with the total area. So we have 1/2 times 44.145, the base 1, plus 14.715, base 2, then multiply to the height of the trapezoid, that is 3 meters. Therefore, y sub c is 1.75. And for the value of our y sub p is equal to, from the figure, so we have 1.5 meter plus this y sub c. So substitute y sub c, thus the value of y sub p is 3.25 meters. So this is from free liquid surface. Next, solving the problem using method number 2, that is the direct equation. So determine the value of F, where F is equal to gamma times h bar times A. Substitute values. So we have gamma of water, that is 9.81 kilonewtons per cubic meter, times h bar. So that is the total distance from CG to free liquid surface. So from CG to the top of the surface, that is 3 meters divided by 2, which is 1.5, plus the remaining 1.5 from the top edge of the surface towards free liquid surface. Therefore, h bar is equal to 3 meters. Then multiply to the area of the surface, that is with base 2 meters times the height, that is 3 meters. Thus, F is equal to 176.58 kilonewtons, that is towards the surface. For the location, that is y sub p, again from free liquid surface, from the diagram, y sub p is equal to h bar plus E. And for eccentricity, E is equal to I all over A times H bar. And for I of rectangular shape, that is 1 all over 12 times B times H raised to 3. Substitute B equal to 2 meters, H as 3 meters, and H bar as 3 meters, then E is equal to 0.25 meter. And substitute this E in equation of Y sub P. Y sub P is 4, or Y sub P is equal to 3.25 meters from free liquid surface. So let's take now our sample problem number 3. So determine the total hydrostatic force and its location. Consider measure from the top of the gate. So for its location. So acting on the 2 meters by 4 meters gate shown in the figure. So for method number 1, the pressure diagram, assign points A and B at the top and bottom of the submerged surface. For layers of fluid, so we will use the pressure P as equal to PA, the air pressure, plus the summation of the contribution of the involved fluids. That is the summation of P all over L sub I. Substitute the pressure of liquids involved, the oil, water, and glycerin. And pressure is equal to H or gamma times H. And for gamma of the fluid, it is replaced with S of the fluid, or the specific gravity of the fluid, times gamma of the reference fluid, that is water. In table form, identify points and P only, since we are dealing with layers of fluids. For points, we have points A and B. For P at A, the sum is equal to 69.8286 kilonewtons per square meter. While for P at B, the sum is 119.271 kilonewtons per square meter. Assign the pressure values at A and B. Then, draw the pressure diagram. Determine the values of force F and location Y sub P. So again, Y sub P is assigned from the top of the submerged plane surface up to the concentration F. Okay, so for F, it is equal to the volume of the pressure diagram, or again, A sub T, that is the area of the pressure diagram, multiplied to L, that is the width of the surface. Substitute values. F therefore is equal to the area of the trapezoid, that is 1/2 over base 1, that is 69.8286, plus base 2, 119.271, and multiply to the height of the trapezoid, that is 4 meters. And with this area of the trapezoid, multiply to the length or the width of the submerged surface, that is 2 meters. Thus, F is equal to 756.398 kilonewtons towards the surface. Next is the location from free liquid surface. But since the pressure diagram is not triangular, then again apply the moment area of the reference line, which is set at the top of the diagram. Rearrange the equation, and before we apply this equation, let us divide the pressure diagram to triangular shapes. We have triangles 1 and 2. Next is to assign the centroid location of the area and corresponding moment arm Y. Update the equation with 2 shapes. Therefore, Y sub C is equal to A sub 1 times Y sub 1 plus A sub 2 times Y sub 2 all over the total area. Assign and substitute the values in the equation. Thus, Y sub C is equal to the quantity for the first shape, we have the area of the triangle, so 1/2 times the base, 69.8286, times the height of the triangle, which is 4 meters. Then multiply with the moment arm with respect to its centroid, we have 1/3 of 4 meters. Then plus, we have 1/2 times the base of the second shape, that is 119.271, times the height, which is 4 meters. And multiply to the lever arm with respect to its centroid, that is 2/3 of 4 meters. Quantity over, so we have now the area of the trapezoid, that is 1/2 times base 1, 69.8286, plus base 2, 119.271, and multiply to the height of the trapezoid, that is 4 meters. Thus, y sub c is 2.174 meters. And since y sub c is measured up to the top of the submerged surface, then y sub p is equal to y sub c. Therefore, y sub p is equal to 2.174 meters that is measured from the top of the surface. Next, let's solve the problem using method number 2. Determine the value of F using P bar, that is the sum of the pressure at the center of gravity multiplied to the area of the submerged surface, capital A. For P bar is equal to PA plus the summation of P over L sub I. Update with involved fluids and substitute for gamma the S of the specific fluid times the reference fluid's unit weight. For P bar, if we will now substitute our values, P bar is equal to PA, that is 30 kilonewtons per square meter, plus for oil, we have specific gravity, that is 0.8, times unit weight of the reference fluid, 9.81, times the height of oil, which is 1 meter. Plus, for water, we have 9.81 as its unit weight, times the depth of water, that is 2. Then plus, we have for glycerin, so the specific gravity of glycerin is 1.26. Multiply to the unit weight of the reference fluid, which is 9.81, and multiply to the height up to the center of gravity. So we have 1 plus 2, therefore it is equal to 3 meters. Thus, P bar is equal to 94.5498 kilonewtons per square meter. For F, substitute P bar and area, that is 2 by 4. Therefore, F is equal to 756.398 kilonewtons. That is again towards the surface of the submerged plane surface, or the submerged plane. So for the location, from the figure, y sub p is equal to 2 meters plus E. The eccentricity E is equal to I all over A times H bar, wherein I for rectangular shape is 1 all over 12 times B times H raised to 3. So we need first to determine the equivalent H bar of the liquid which is in contact, that is glycerin, by equating the equation of F for homogeneous fluid and layers of fluids, that is gamma times H bar times A equal to P bar times A. Cancel A and rearrange the equation. We have therefore H bar as our unknown equal to P bar, already determined earlier, over gamma. Substitute P bar and gamma of glycerin, wherein P bar is 94.5498 and gamma of glycerin, that is 1.26 times 9.81. So for H of merely glycerin that is exposed to the atmosphere, so we have 7.649 meters depth of glycerin. Substitute in equation of E. So we have B, that is 2 meters, H 4 meters, and H bar determined as 7.649 meters. Thus, E is equal to 0.174 meter. So in equation of y sub p, we have 2 meters plus E that is 0.174. Thus, y sub p is 2.174 meters below the top of the submerged surface. So which is the same as the first method. So for various problem, it is your discretion on what method or formula to use as long as you are comfortable of using it. So that's it for our topic, hydrostatic force for vertical plane surface. Take care and God bless.